G'day. Welcome to Crystal Clear Mathematics, where it is easier than you think. I'm Graham Henderson, and we're continuing our series about hyperbolae and asymptotes. So far we've learned what an asymptote is and what it looks like when you draw one, or at least draw a graph approaching one. We've learned how to locate where a hyperbola is and how to draw one on a graph, and to locate its point of closest approach to the origin. In this particular video, we're going to talk about this. What happens when we have an equation with a negative number on the top? Or, if we multiply both sides of it by x, when we're trying to analyse that equivalent equation, xy equals minus 2. Well, something quite simple takes place, but until you've seen it for the first time, you may not have any intuitive sense of it at all. That's the way learning is. So we draw our little graph. Whoops, minus 4. I like to talk in terms of this expression. What numbers would I multiply together to get minus 2? Well, let's start on the positive side of the graph. I'd have to multiply 1 by minus 2. Now that's different. All of our graphs previously have been in this first quadrant and third quadrant. By the way, the quadrants are called 1, 2, 3 and 4 just so we can explain where things happen on a graph. But that's where all the graphs appeared in the previous two videos. In this one, it appears down here. Now also, I could multiply 2 by minus 1 to get minus 2. I could multiply 4 by minus a half, or a half times minus 4. So you see we have exactly the same pattern. Ooh, this is a bit harder to draw on a whiteboard than on a page in a book, but that's the same shape, exactly the same shape as we had up here before. Over here we have a similar thing happening. At minus 1 times plus 2 would give a negative value. Minus 2 times plus 1 would give a negative value, and minus 4 times a half times 4, and we would get the hyperbola drawn here. I apologise, I didn't go through the points properly. So instead of being in these two quadrants, they're now in these two quadrants. And this pattern is typical, absolutely typical, of having a negative numerator or a negative constant over here. So if I was graphing, for example, y equals 4 minus 4 over x, or xy equals minus 4, whichever you prefer, then I'm looking for numbers that multiply to give negative 4, or minus 4. 1 times minus 4, 2 times minus 2, 4 times minus 1, and you can see that the graph is further out because we have a bigger number. Here, minus 2 times 2, minus 4 times 1, 1 times minus 4, and it's further out. Now, what about the point of closest approach? Well, certainly I think you can see it quite clearly for this graph. Minus 2 and 2. But we've got to think a little bit more differently than we did in the previous video, because in the previous video all we did was take the square root of this number, and here we have a negative number, and you can't take the square root of a negative number, at least not in the real number system. So what we have to understand is that one of these two numbers here, x or y, must be negative, and if it's negative, then that will take account of that negative sign, but the actual values, the size of the number of x times y would give 4, so both of them would have a size of the square root of 4, which is 2. It just means that one of the numbers has to be negative to produce this negative value. So here we are at minus 2, 2, and 2 minus 2, or 2 negative 2, as the point of closest approach. With this previous one in black, the point of closest approach would be the square root of 2, but remember that one of the values would have to be negative. So here, for example, I would have square root of 2 times minus the square root of 2, and here I would have minus root 2 times plus root 2. So for here, in the second quadrant, I'd have a negative x value and a positive y value, and here in the fourth quadrant, I would have a positive x value and a negative y value. So in this case the x is negative, in this case the y is negative, but the point of closest approach is still the square root of the number on top, stripped of its minus sign. So there we go. We've now learned what an asymptote is, a line towards which a curve will approach forever and ever, but never actually reach it. We've learned that the larger the numerator is, the further away the hyperbola is from the origin. That in fact the square root of that number tells us the point of closest approach. And we've learned that a negative sign means we're working in the second and fourth quadrants like this, but a positive sign means we're working in the first and third quadrants. In my next video, I'm going to explain what happens when we start tampering, not with the constant on the top, but tampering with the x and y values. So I look forward to seeing you for that. Please leave your comments, please click the like button, and please subscribe so you can hear about the future videos as they appear. And I thank you for watching.